Good day, class. We're going to go ahead and go over our test review right before taking this test. It has to do with trigonometric identities and also has to do with inverses of trig identities. Now, let's go ahead and get started. Now, one of the things I do suggest before, a couple of things. You have to have your unit circle. Make sure you have this out because you're going to be referring to this constantly when we're looking at this. And the other thing I suggest is go ahead, after you're done with this video, pause it and make sure that without looking at the video, you can recreate every problem without listening to what I did. It doesn't do much help if you can't remember this information. And the way you test yourself and remembering the information is by going ahead, pausing the video, or rewriting these questions and redoing all the questions by yourself. And then if you have trouble, go back and look at the work or look at this video. Now, let's go ahead and get started. Now, on question 1 says, find the exact value of each expression using your unit circle. One of the things we got to keep in mind is that when we deal with inverses, specifically this, when you have that negative one that shows up on there, something happens that in order for us to find the solution, we could only use quadrant 1 and quadrant 4 in the unit circle, which means that in particular, in this case over here, none of this is going to be used, just this side over here, because with inverses you go from negative pi divided by 2 to pi divided by 2, and your answer must be given in that format, which means that when you write your answer here, it must fit between these values. And the unit circle that you have in front of you, it's not necessarily set up with that. Now, you may have it, and what I mean is that you may have your unit circle where you're signifying this is negative pi divided by 6, and you may have that this is negative pi divided by 4. The reason why I'm bringing those items up is because when you write your answer, you got to make sure your answer, if it fits in this side, on this side of the quadrant, has to be written, like if it fits here, unit 4, your answers need to be written in this kind of format. That's important because otherwise you might just go ahead and say, oh, it's 11 pi divided by 6, but does not fit within this format in here. So you got to make sure you do that. So now let's go ahead and do this. Now let's negative pi divided by 3. Remember, sign is y, so when I look at this, I look for negative pi divided by 3, or 2 in the y section, and there it is. Now here's a perfect illustration that shows you that you need to be specifically looking. Now I'm going to go ahead and look for specifically this value right here. And looking from the other side of the unit circle, you can easily tell that this is negative pi divided by 3. So when you write your answer for this one, you're going to go ahead and write negative pi divided by 3. Now let's go ahead and move on to the next one, cotangent. The cotangent is really just x divided by y. So what we're going to do in this case, let's go ahead and you're going to go ahead and you're still going to use the same quadrant. Remember, cotangent is related to tangent, which means you still use quadrants 1 and 4. Now you might be wondering, well, when is it that I don't use these quadrants? It's only when you're dealing with other ones like cosine, like this one down here. That's the ones you use quadrants. Well, we'll get to it, but you only use quadrants 1 and 2 for cosine. But you got to make sure that you memorize that sine and tangent use these quadrants 1 through 4. So which means that also signifies that I'm still going to be using this kind of domain when I get my answer over here, or that kind of format when I write down the answer. Now, one thing to keep in mind, it's probably a good idea for you to have your unit circle with the tangents written down. But remember, cotangent is x over y. So one of the things that, noticing that this is a positive number, you're going to look for the value. When you deal with this, you're going to look for the ordered pair that when you divide them, x divided by y, it's going to give you square root of 3. So let's go ahead and identify that ordered pair. So let me go back to my unit circle. And let's look at this one. Remember, this is x and y. And if you do square root of 3 divided by 2 divided by 1/2, I think that's going to be the answer right away. The reason why I mentioned in this kind of way, remember, this is, and what I mean specifically, this is x and this is your y divided by. Okay, so the reason why I'm doing this is because, remember, most in your unit circle, you might have all the tangents written. Most likely you don't have the cotangents written, so it'd probably be better if you did like a trial and error thing. So the reason why I know this is going to work is because when you do, here, I'll bring it down over here. square root of 3 divided by 2 times, remember you take the reciprocal of the denominator. This reciprocates. So you multiply, this gives you square root of 3, which means that this is my answer, pi divided by 6. So when I go back over here, I'm going to write down the answer, pi divided by 6, and that's my answer. Now let's go ahead and evaluate these. Now with these right over here, one of the things we got to keep in mind is that we're going to evaluate this. We're still going to follow PIMDAS, so we're going to evaluate this part of it first. And then afterwards, we'll evaluate the inverse part of it. Now, when you just see sine by itself, the way you see it now, there's no inverse to it, which means you can use the whole unit circle. So what I'm going to do particularly with this one is, let me go ahead and actually I want to bring out another unit circle, because I want to go ahead and actually be able to reference back to it and not have to erase what I have done already. So let me bring another one out. Okay, so here's my unit circle. Let me make sure I could resize it, make it look nicer, make it look something that we could go ahead and read a little bit better off of. Now, let's look at the value that we're looking for. 5 pi divided by 4. So when I go back to my unit circle, I'm going to identify 5 pi divided by 4. And let's see where that's at. Oh, right here. This is, ooh, I moved around because I have not yet written my marker. Okay, so 5 pi divided by 4. And I'm looking specifically for the y value, so which is this, negative square root of 2 over 2, which means that when I deal with this answer, or this solution here, I will be writing sine negative 1 of square root of 2 divided by 2. That's what I'm going to be writing. So I'm going to take the inverse of that. Now, when I go ahead and take the inverse of this amount, this is when I need to go back and use this idea here. I want to keep on circling it over and over, but I got to use only that part of the unit circle and these quadrants that I've been writing down here. Now, so which means that when I go back to this part, I'm going to look for sine of that value, which is here, and here's my answer, pi divided by 4, which means that over here, I'm going to write equals pi divided by 4, and there's my solution. And now, this is an example of the right process. Here's going to be another example of the right process. Now, with this one in particular, you see how this one has the negative 1? I'm going to go ahead and bring on my unit circle again, or in particular, let me use this one right here, because with cosine, you cannot use any of this. Cosine deals specifically with quadrant 1 and quadrant 4. So I'm going to go ahead and look at the x values in just in those two quadrants. And the value that I'm going to be searching for is going to be this, negative 2 divided by 3. So let's find that value, negative 2 divided by 3. And when I look at my cosine values, let's see, negative 2 divided by 3, it doesn't show up, which means we need to do something in particular. We need to find opposite over, I guess, the opposite over the amount of this one. This one's going to be worked a little differently, because in this case, once you run into this situation, it means something specific. It means that it's not part of the unit circle, which means we need to take a different type of strategy with this to solve it. With this one right here in particular, our answer, our cosine answer, my answer is going to be written, answer theta is going to be written then in the format of adjacent over hypotenuse. Okay. And right now, I'm looking at the inverse right now of negative 2 divided by 3, which deals with that this is adjacent and this is hypotenuse of that value. So let me go ahead and just double check on something real quick. Now with this answer in particular, we got to remember something that's very important for us, that when we deal with the cosine and we deal with the kind of like cosine inverse or whatever function we're looking at, whatever value we're looking at, so let's say of x, okay, we have a certain domain that we need to, that this is going to be restricted to, or better put, that this is going to follow that it has to go between the values of negative 1 to 1. Now when I go ahead and compute this negative 2 divided by 3, I actually get negative 0.6666666, which means in this case that it fits in here. If it fits in here, then you're just able to cancel out these cosines and say in this case you have negative 2 divided by 3. Now the way I was planning to do it over here is the same kind of the same technique. See how it says negative 8 and h? We have those values already for the cosine of that value, so which means we would have got negative 2 divided by 3. I guess the most important thing we got to keep in mind is to make sure that it does fall inside the domain of these values. So let's go ahead and now move on forward with this, and let's establish some identity properties right here. Now, keep in mind, one of the first things I want y'all to do is concentrate on the harder side. Make sure you have your green sheet with you. And what I mean by the green sheet is the one that has all the identity properties. Now, I'm going to go ahead and convert this. Tangent in itself is sine theta all over cosine theta, divided by cosine theta. Cotangent, in this case, is going to go ahead and be the other way around. Cosine theta divided by sine theta. Now, if you knew your cotangents and tangents real well, you would know that there are inverses. But most of you, some of you may not have that in mind. So if you don't know that, then it's better if you did the conversion, and identified that they cancel out, and you're left with 1. So you become 1 sine squared theta equal to cosine squared theta. And this part right here is an identity property. And what I mean is that this becomes cosine squared theta is equal to cosine squared theta. And therefore, you have to solve. Checks off. You can go ahead and say you've solved it. Now let's go ahead and move on to question 6. Question 6 moves on to establishing more identity properties. Again, first thing we should do is go ahead, well, this is already in that kind of format, and where we have 4 cosine squared theta to 3 sine squared theta. Again, we're going to go ahead and focus on the more difficult side to make this work. Because we also could do, let's see, I want to go ahead and say I want to pull out that 4 and the 3 and make this easy, but it's, if I pull out a 3, 4 sine squared, because I'm looking at these two right here, and I'm saying, oh, that I know that definitely is 1. But before we do that, let's go ahead and actually work with this and see what is it that we could do with it to make it really talk about the different possibilities that could be done here. Now, one of the things I could do is I could go ahead and move some things around. Actually, that's what I'm going to do in this case. I'm going to move some things around just because I'm noticing that I'm able to factor, and I'm also able to get some identity properties in place. So let's go ahead and actually maybe strategize about what will be the best thing in this case. So now the first thing I'm going to do is I'm going to go ahead and convert, since I'm dealing with cosines, I'm going to go ahead and convert that sine squared into cosine. So let me go ahead and write that down. I'll have 4 cosine squared theta plus 3, and I'll have 1 minus, oops, not sine. It's going to be 1 minus cosine squared theta. And I still have it equal to 3 plus cosine theta. And what I'm going to do here, I'm going to distribute those two values. So I'll end up with this 4 cosine squared theta is equal, well, not equal to, let me erase that. It's going to be plus. Yes, so we'll get 3 minus 3 cosine squared theta is equal to 3 plus cosine squared theta. All right. Now from here, I'm going to go ahead and just cancel out the 3's. You all see how we have 3's on both sides? And that's going to assist me because, yeah, it just makes things simpler. Okay, if I subtract 3, I subtract 3. They cancel out. And then from there, I'm actually now just left with cosine squared theta. Now, in reality, you don't need to cancel them. It just, for me, I'm seeing it and I'm just saying, okay, it's going to make this, I'm visualizing this to become this. Cosine squared theta, or is it minus 3 cosine squared theta. And in this case, I have this equaling to cosine, actually I forgot the square here. I was looking at the end result and I was like, something's missing. Now, from here, I have these cosines that they have in common, so let me highlight these. This one and this one. So what I'm going to do is I'm going to go ahead and factor those out. So when I factor those out, I'll have cosine squared theta, and I'll be left with 4 minus 3 equal to cosine squared theta. Now, this 4 minus 3 is just 1. So cosine squared theta times 1 is equal to cosine squared theta. And from here I improve because 1 times this is cosine squared theta. So it's done. I have it checked off. All right, excellent. Now let's go ahead and deal with number 7. Now number 7, I have things as cosecants, cosine squared 4. What I'm going to go ahead and do is I'm going to make these into sines and cosines so we could be a little bit more familiar with what we're looking at. Now, I'm going to go ahead and erase all this, so if you need to somehow copy all this, go ahead and just review the video, and you'll be able to see all that work in itself. So let's deal with the next part of this, and we're specifically now looking for, let me change cosecant squared theta. Remember, this is really sine squared theta plus 1 over sine squared theta times, in this case, square. Cotangent is cosine squared theta all over sine squared theta. So the only thing that I'm missing, because I like to get a common denominator in this case. Oh, and this is equal to 1 over sine squared to the theta to the fourth. Let's see. Remember, at this stage, you have the possibility of doing a couple of different things. You could go ahead and factor things out. That's a possibility as well. Let's see, we have 1 plus cotangent. Actually, that's one of the things that if I probably could factor the cosecant square out. Be left with 1 plus cotangent of that. And that actually may be an identity property. I'm looking at this and I'm thinking, I'm actually looking at it and I'm thinking that I might take a different course with it because I'm noticing some things. I'm actually, one of the things I noticed right away is I'm able to factor some things out right now that I wrote that down. And remember, it's not uncommon for you to go ahead and for this to happen, for you to try something and then figure out you got to try something, but probably you might figure out that something might be better. Now, one of the things I wanted to now, what I saw is this. If I factor out this cosecant, I'll have cosecant squared theta, and I'm going to be left in this place. So 1. Now, the 1 comes from here because remember, this is really times 1. So when you pull that out, you're just left with that 1. On this side, you're going to be left with cotangent. Oops, not cosine, cotangent. Hold on, let me fix that. You're going to be left with these cotangent squared theta, and you'll still be left with cosecant squared theta. Now, one of the things I realized is that this is related to cosecants when I was looking at the green sheet. So when the green sheet or the identity sheet, we went ahead and found out that we have 1 plus, and I'm going to go ahead and now substitute what this is. I think it's 1 minus cosecant squared theta. When you look at your identity sheet. And that's going to be equal to cosecant 4 theta. Now, since there's nothing on the outside of this parentheses, you're pretty much going to remove it. There's really nothing there that's preventing you from doing that because it's being distributed by 1, if anything. So one of the things you realize that these cancel in itself. And now you're left with, let's see, you're left with cosecant squared theta minus sine squared theta. So let me make sure I have that all correct there. So actually the other way around, actually in the when this should have been done, now I'm looking at it, and this is why it's important to look at the identity sheet when you're writing these things down. If I cancel something I shouldn't be able to cancel, but the actual theorem that what this substitutes, cosecant squared theta minus 1. So those do cancel, and you're just left with this. So you're left with cosecant squared theta multiply by cosecant squared theta equal to cosecant 4 theta. Now when I go ahead and multiply these two, I'll get cosecant, square, not square, hold on. I'll get cosecant to the 4th power. So I'll get cosecant to the 4th theta equal to cosecant to the 4th theta. And from there, you have checked off. You know that you have an answer. All right, now let's go ahead and work on the last ones of this review. And this one says, draw a sketch of each central angle of the correct quadrants and find the missing side by using SOHCAHTOA and Pythagorean Theorem. Now, one of the things we got to keep in mind when working on these is that our end goal for this is to get sine theta equal, remember this is opposite over hypotenuse. This is what my answer is going to be. So my answer is going to be a derivative of what those two are. Now, one of the things I do know already, this is adjacent over hypotenuse. So I actually have my hypotenuse answer, 5. I could write that in. What I don't know is just this little part, what is the opposite mark? There's a number there that is missing that I need to find out. So let's go ahead and actually use this to identify what we're going to be doing with this. Now, when you're dealing with this cosine, okay, and you're dealing with negative values, you're actually going to be dealing with quadrant 2. This quadrant 2 deals with negative cosine values. So when you draw your central angle on this, it's going to have this kind of idea. You'll have your central angle. You'll have this being negative 2. Hypotenuse is 5. What I don't know is what's my opposite. Now with this in mind, you will know Pythagorean Theorem, which means you got a squared, a, b, and c. A squared plus b squared is equal to c squared. And an application of that, negative 2 squared plus my unknown squared is equal to 5 squared. If you go ahead and add 2 squared, add 2 squared, and you'll go ahead and actually get, in this case, b squared is equal to the square root of 25 plus 4, which means that, well, I probably should have done, I went ahead and did the square root already, so it means you have the square root of 29, which means in this answer over here, this value in particular, let's go ahead and make this the square root of 29. Now, if you're ever in doubt, if you have a, did I do this correctly? You can go ahead and put it back in and see if it works and see if you actually do get the right value. So, like in this case, if you wanted to see if you actually equal 5 squared, you could go ahead and actually test it out and see if you actually get it. And in this case, you know what, I think it was right here where I might have committed the mistake, because I think before, okay, order of operations. I knew that when I looked at this and I was writing it down, I realized something. I realized I might have done something wrong in the order of operations, and I did. This is not the right answer. What I did is that this part of the order of operations, and the reason why, and what I ended up doing is say, I'm going to go ahead and test this to make sure I have the right answer. I realized that if I take 29 squared, square root of 29, plus, in this case, negative, it's negative 2 squared, I will not end up with 25 squared. It just won't happen. It just won't, it will not end up being 25, which is 5 squared. And I'll tell you where the mistake happened and some of the reasoning that I did. The reasoning came from here. And just to show you, square root 29, that becomes 4. This is 31, it does not equal. Now, where did the mistake occur? It happened exactly at this point right here. So yes, I went ahead and said that you could do this. This you cannot do because you're not following PIMDAS. And what needs to occur is this. You need to first, let me erase all this right here. You need to first square the value before you subtract it. So let me go ahead and erase from the mistake error so we could go ahead and do it correctly, how this is all going to look like. This was negative 2 squared. The first thing you got to do is square that, and you'll get 4 plus b squared is equal to 25. And then from here you subtract 4, you'll get b squared is equal to 21, and then you take the square root of this, and you find out that this really should be the answer. Your answer really should be the square root of 21, which means that when you do this, if you wanted to test it out now, Square root of 21 squared plus negative 2 squared is also equal to 5 squared. Those cancel. 21 plus 4 is equal to 25. And this checks out. So tested it twice, probably a little bit too much work, but I just wanted to double check on that part just to verify that if you do whatever answer you get, go ahead and try it, because I want to make sure you know that you got it, you have something that is 100% correct. All right, now let's go ahead and deal with this next part right here. Also, in conclusion, here's your answer. Question 8. Now let's do question 9. Remember, your answer on question 9 is going to be tangent, angle, and that's going to be opposite over adjacent from the SOHCAHTOA part. Now what am I given? I'm given secant. And secant is hypotenuse over adjacent, which means that one thing already, I could go ahead and actually, well, okay, so I know automatically that part of my answer is actually going to be 3. What I don't know is what's my opposite side of this angle. Now, one of the things I could do is I could go ahead and figure that out. Now remember, secant is related to sine. So it's related to sine. You're still dealing with quadrants 1 and 2, which means that this central angle is going to be in quadrant 1. This is 3 and this is 7. What we don't know is what's the opposite on this one. So in this case, let's go ahead and do what we did before. Similar processes as far as Pythagorean Theorem. We'll have 3 squared plus b squared is equal to 7 squared. 9 plus b squared is equal to 49. Subtract 9, subtract 9. This cancels. This becomes b squared is equal to 40. Take the square root of both sides. You find out that b. Now, so getting back to this, so my answer should be the square root of 40. So this is my opposite side. So this really should be the square root of 40. Now, again, just to, if you want to verify, just go ahead and plug it in. You got to make sure that it equals. So if you want to go ahead and verify that this is the right answer, or the square root of 40 is the opposite, then you just do square root of 40 squared. So that's one of your opposite, one of your legs. 3 squared, and that's equal to, oops, equal to 49. And really what I did is 7 squared. These squares cancel out. You got 40 plus 9 equal to 49. 49 does equal 49, so that's the right answer. And we are done. Now, one of the things you should be doing is looking up definite identity properties and just practicing them. Practice the different strategies that go along with them. And you should go ahead and actually just practice. Make sure you're able to remember the 3 most important things you could do now that you watch this video. Try it again. You got to make sure you're able to remember without me watching or you looking at your paper. You got to make sure you understand what's going on. And lastly, you got to be able to apply it. Very important. Please do this. To do this, you'll find out you'll have an easy time with the test. Thank you.